This is the smart contract that we are going to test. It is a basic ERC20 token that implements the MIT license. I'm using the compiler 8.22, and also I'm importing two libraries, the ERC20.sol library from OpenZeppelin and the Ownable library. The contract name is token. I'm inheriting from the ERC20 and Ownable libraries. The max supply for the token is equal to 1 million Ether. Remember that the notation here means that I'm adding 18 decimals. Now I have an event. This event will log the owner or the minter, the address of the receiver of the tokens, and then the amount minted. The constructor is very simple. It receives the name of the token and the symbol, initializes the ownable contract, and also initializes the ERC20 token library. And finally, we have a mint function here that receives two parameters, the amount of tokens that I'm going to mint and the receiver of those tokens. This function can be called only by the owner. Here, I'm just adding a very simple condition. The function is going to mint tokens only if the total supply plus the amount is less or equal than the max supply allowed. In this case, 1 million Ether. If this requirement is successful, then I'm going to mint the tokens. And finally, I will emit this event. So if we try to test this contract here, I need to specify the name, my token, and the symbol, MTK. I will transact. I will send the transaction. And then here I can test all these functions. Some of them are very simple. If I call the function decimals, I obtain the 18 value that is equal to the number of decimals for this token, the name of the token, the owner, the symbol, the total supply in this case is equal to 0. And then I can start testing some of these functions. However, if you require more complex scenarios, this is not going to be as simple as we expect. Let's test a more complex scenario. For instance, let's copy another address here. I'm going to copy the second address, and then I'm going to mint new tokens for this address. In this case, I'm going to mint 1,000 tokens, and I'm going to send those tokens to the new account. I will send the transaction here, and now the total supply is equal to 1,000. However, if I want to transfer now to another account these tokens, for instance, here I'm going to change the account. I'm going to copy this first account, and then I'm going to switch to another account here, and I'm going to transfer some tokens. I'm going to transfer half of these tokens, and I'm going to send the transaction. Now, if I check the balance of this account, this is going to be equal to 500. But let's say that I make a small change here, and I need to redeploy this contract. So if I send the transaction again, my token, MTK, all the previous tests that I made here are gone. So I need to do everything all over again. To solve this, I can use Hardhat to test my contracts. So let's move to our Hardhat project. Welcome to DappDojo. If you like this content, don't forget to subscribe, like, and ring the bell button. Your support is very important for us. If you want to become a smart contract developer, follow the website courses.dappdojo.com and join the course Mastering Web3, Bitcoin and Blockchain. This course is perfect for beginners or blockchain enthusiasts looking to deepen their understanding of Ethereum and Web3 technology. We are offering a 100% off coupon to join for free. In this course, we cover everything you need to start with Web3 and blockchain technology. You can find the link and all the information you need in the description of this video. Thank you and welcome to DappDojo. Now let's test our contract using the Hardhat IDE. If you have some troubles installing Hardhat and configuring Hardhat to compile and test your contracts, review the previous video about Hardhat where I show you how to install and configure your Hardhat environment. In this case, I just copy the token.sol file to this project. I also install the OpenZeppelin libraries, and we are ready to start testing this contract. In the folder test, I create this file token.js. This test will implement fixtures, and it's importing this from network helpers. I'm also using Chai, and I will be using the expect assertion. Here I define some constant values, for instance the value 0, the value 1 that will be equal to 1 ether, 1 million represents 1 million ether, and also the 0 address. Here we have the describe from the Mocha framework. Remember that describe will help us to organize our test. First, we define a fixture to reuse the same setup in every test. We use load fixture to run this setup once, snapshot the state, and then reset Hardhat network to that snapshot in every test. So basically the fixture will allow us to reset the Hardhat network in every test. Now we use ethers to get the signers. We are using 3 accounts, the owner, the sender, the receiver, and then we create an instance of the contract. In this case, I'm using ethers.getContractFactory. I call the contract token, and then I deploy this contract and create an instance. Notice that here I send the 2 values to the constructor, the name of the token and the symbol. Then I just create here, I just mint some tokens to the sender account. I am minting 1 ether, or the equivalent to 1 token with 18 decimals. I'm using this assertion, expect not to be reverted. So I assuming that the owner, in this case the account owner, is sending this transaction. By default, we always use the first account. I'm sending this transaction and it's not going to be reverted. And then the fixture returns the token contract, the owner, the sender, and the receiver. Now let's go to the second describe in this test. This describe is about the deployment. And here in our first test, we verify that we should set the right owner. Notice that this is an asynchronous function, and I am executing the fixture. This is an asynchronous call, so I need to use the await keyword. Then I use the assertion expect. I call the owner getter here, and it should return the first account. In this case, that account will be owner. I only verify that it's equal. I can also add to be equal to make it to compare the 2 objects. If I want to verify that everything is working properly, just type the command npx hardhat test, and everything is working. So this is the first test. I just verified that the deployer account is equal to the first signer in this test. Now let's write some different tests. For instance, here we are going to validate the account's balance. To verify the account balance, let's use again the expect assertion, and then let's call the function token.balanceOf, and let's check the owner. The balance of this owner should be equal to 0. Let's run the test. This is working properly. Now let's test another account. Let's execute the assertion expect again and call the function token.balance of the sender to be equal. In this case, because when I run the fixture, the sender receives 1 ether, then I need to, or 1 token, I need to specify the value 1 here. Let's verify again our test, and this is working properly. Now let's check something different. In this test, we should not allow to mint more than the max supply. Now let's call await expect token dot mint sender and 1 million. I'm gonna try to mint more than 1 million, but remember I already minted one token or 1 Ether in tokens, so this is not going to work. We should expect to be reverted with the message max supply reach. Okay, let's verify if this is working. There you go. This is working because I cannot mint more than 1 million. And remember here in the fixture, I already sent or mint one token to the sender. Also notice here that the await is not inside the expect assertion. It is outside. You need to be careful with this because we are not evaluating the result. We are evaluating here if this function is going to be executed. So if this is executed, it should revert with this message. The difference here is that we need the value that is returned. In this case, the value is going to be 0, and in this case also the value is going to be 1. So that is why we have the await inside the expect assertion. Let's continue with our test. In this test, we should not allow to mint to 0 address. Let's call the expect assertion. Now let's call the function token.mint, and we are going to try to mint to the 0 address, and let's try to mint 1 token. So this is going to be reverted with the message inside the function. Here the message is the receiver is the 0 address, so this is not going to work. So the message is going to be 0 address. I made a few changes here in the token contract. This is just to add some validations. For instance, I require that the receiver is not equal to the 0 address, and I'm also verifying that the amount is greater than 0. So I just add this last minute to show some different examples validating the required statement. There you go. So now I'm able to validate this test. Let's move to the next test. In this test, we should not allow other account to mint tokens. We start creating the text with await, expect, and then token. But in this case, I'm going to use a different account. I'm going to connect the account sender, and I'm going to try to mint to also the sender, and I'm going to try an extra token or an extra Ether token. But this is going to be revert differently because here when I try to mint, the modifier on the owner will prevent that an account different to the owner tries to mint and call this function. Then inside the ownable library, the Open Zeppelins team uses custom errors. So here, this is not going to be reverted with custom error. The custom error needs to specify the contract, in this case token. We need to specify the message. For instance, here, let's call this, and this is going to create an error. We need to specify the name of the custom error. In this case, if you don't know it, you need to go to the library and see what is the error. Because I already know the error, I'm going to write it here. Ownable on authorized account, and let's see if this is working. There you go. So this is going to revert with this custom error. We can also add the argument that is failing here with arguments, and the argument that is creating this problem is sender address. So when this reverts, it also reverts with this custom error and reverts with this argument. So let's see if this works. There you go. Now let's verify that we are able to emit an event. Let's start again with await, expect, and then let's emit this event. Let's mint some tokens to the sender. Let's mint 1 Ether, and then to emit and the name of the contract token, and the name of the event. In this case, it's going to be log mint. Let's also add arguments of this event. This is going to be the owner, the sender, and the amount is going to be 1. So there you go. So in summary, I'm verifying that when I execute this function, I'm emitting this event with these arguments. Let's see if this is working. Now I'm able to emit an event when minting. Let's verify if I'm able to transfer tokens. To verify that I'm transferring tokens, again, I'm going to use await, expect. I'm going to try to transfer some tokens, but because the only account that has token now is sender, I'm going to connect this account, sender.transfer receiver 1. Something important here is I need to verify that the amount of tokens that I'm transferring will be reduced from this account and then added to the second account. So I'm going to use the option to change token balances and the name of the contract, and I also need to specify the sender and the receiver accounts, and I need to specify how the balance of this account is going to change. In this case, for the sender, it's going to be reduced by 1 token, and for the receiver, it's going to be increased by 1 token. So there you go. Let's test again. Oh, voila. This is working properly. Now we can do the same with Ether. This is an example to show how can I validate when I'm transferring tokens, but I can do the same when I'm transferring Ether. For instance, here, I'm going to use, again, the await, but this is going to be a bit different. Expect, and then I'm sending a transaction here. This transaction will be executed by the sender, send transaction, and the transaction will send some Ether to the receiver and some Ether. And I need to specify some Ether. In this case, it's going to be 200. I need to verify how the Ether balance changed for these two accounts. So to change Ether balances, and I need to specify both accounts, sender, receiver, and how the balances will change. Minus 200 and also 200. Let's verify if this is working. There you go. So everything is working properly. It is possible to change the Ether balance of just one account. In this case, I only need to specify the instruction change Ether balance. I don't need this array. And for instance, I can do this and also specify one change. So it's not mandatory to change both balances for the sender and the receiver accounts. But in this case, it's very useful to verify that the sender reduces its Ether balance and the receiver increases its Ether balance. Just make sure that everything is working fine. Okay, I made a mistake here. Sender, receiver is change Ether balances. Now let's validate the allowance for our token contract. First, let's verify that it is not possible to transfer on behalf of another account if I am not approved. Let's create our first test here. Await, expect token dot transfer from. In this example, the owner is going to try to transfer Ether on behalf of the sender to the receiver. It's going to try to transfer one token, and this is going to be reverted. Let's check this. This is failing because I'm not approved to transfer tokens on behalf of the sender. So now let's approve the owner account. This is going to be by connecting first the sender and calling the function approve and specifying that the owner is allowed to spend one token or one Ether on my behalf. There you go. Now let's check again. And now let's verify if I'm able to transfer the tokens. Okay. Then let's check that the balance is changing properly. Token balances, specify the contract. So now the sender and the receiver will decrease and increase the number of tokens. There you go. So what I'm doing here, first the sender is approving the owner to spend 1 token or 1 Ether on behalf of the sender. Then the owner here, I'm not specifying the owner here, so by default this function is called by the owner. The owner is transferring from the sender to the receiver 1 token. And then I verify that the sender and the receiver change its balances by 1 Ether. Let's check if this is working properly. And there you go. So as you can notice here, I have already different techniques to test our contracts. Every test is different, and in every test I'm validating something completely different. So please spend enough time creating your test and validating your business logic. Remember that the contracts will store a lot of money. So it is really worth it to spend enough time validating and testing your contracts. Thank you.